In this lesson we'll look at the cosine rule, but first some general conventions for triangles. What you see here is a triangle, obviously, and a triangle has three vertices, which I can call A, B, and C. Now these are capital A, B, and C. Yeah? That's how you denote points or vertices, with capital letters. Now the convention says in a triangle that if this is the vertex A, then the side opposite this vertex here you are most likely to call lowercase a. So that length here is A. Opposite big B is the side called B, lowercase, and opposite C is the side called C, lowercase. Any triangle, so here as well, if this is triangle ABC, then this is C, this is A, this is B, right? Now what we're after here is the cosine rule, and I'm not going to prove it to you, but let's have a look here at this triangle first. This is a right angle triangle, or it is now. And in that right angle triangle, you know from Pythagoras that c squared is a squared plus b squared. The hypotenuse is the shorter side squared plus the other shorter side squared. That's what Pythagoras says. Now, this is not a right angle triangle. C is not a hypotenuse, and A and B, there's no right angle there. So obviously c squared is not the same as a squared plus b squared. But it turns out though that it's pretty close, or at least there is a formula which has Pythagoras in it. The formula is called the cosine rule, and it's like this. C squared is indeed a squared plus b squared, but we have to make up for the fact that this angle is not 90 degrees. How do we do that? We take away 2 times a times b times the cosine of the angle at C. So these are all lowercase. C squared is the length of this line here, segment. A squared and b squared are the length of these segments. And C, big C, is the angle at C. So there's your cosine rule. Now again, this is not a proof. The proof is in the book. But this is the cosine rule. Now I can twist this cosine rule around. That's the beauty of it. So if c squared equals a squared plus b squared, take 2ab cosine c, I might as well say a squared is b squared plus c squared, take 2bc cosine a. It's the same thing, but looking at it from a different perspective. Or b squared is a squared plus c squared, take 2ac cosine b. All the same, all the cosine rule.